So hello guys. So we are continuing the part 2 discussion from this chapter, that is principles of inheritance and variations. So in last class we have discussed around 54 questions. So today we will be discussing 50 questions onwards. Okay. So if anyone have joined, just let me know in chat. Yes, yes. Okay, let's start guys. So here today we will be discussing question number 55 onwards. Okay. Yes, yes. Here you can see the question. Here we will be discussing questions related to NEET exam, mainly NEET exam. And today we will be discussing from, from chromosomal segregation till end of this chapter. Okay, fine. So here the question is given below are two statements. Statement one, failure of segregation of chromatids during the cell cycle resulting in the gain or loss of whole set of chromosome in an organism is known as aneuploidy. Statement 2, failure of cytokinesis after anaphase stage of cell division results in the gain or loss of a chromosome is called a polyploidy. So what will be the answer here? Tell me. Here you can see that in statement 1, failure of segregation of chromatids during cell cycle results in the gain or loss of a whole set of chromosome in an organism is called a aneuploidy. You know that um, if whole set of chromosome is coming, which is called a polyploidy. This is called a polyploidy, not aneuploidy. Hence, this statement is wrong. Right? Now, in statement 2, failure of cytokinesis after anaphase stage of cell division results in the gain or loss of a chromosome is called polyploidy. You know that polyploidy means change in a whole set of chromosome, not a single chromosome or not a few chromosome. Hence this also not correct, wrong only, right? So polyploidy means what? N will be converting into 2N, which means a whole set of chromosome has changed, right? But what is polyploidy? What is aneuploidy? Aneuploidy means, let's say 2N converting into 2N plus 1 or 2N minus 1, 2N plus 2. All these are examples for aneuploidy, which means the chromosome number, there will be a few changes in the chromosome number, like increase in one chromosome, two chromosome, or a decrease in one chromosome or two chromosome. This is called aneuploidy. Polyploidy means what? Let's say 23 chromosome. N is equal to 23. This is converting into 46 chromosome, becoming 2N or a double. This is called a polyploidy. Clear? So here answer will be option D. Yeah, very good. Now let's take another question. Aneuploidy is a chromosomal disorder where chromosome number is not exact copy of its haploid set of chromosome due to substitution, addition, deletion, translocation, inversion. Choose the most appropriate answer. Guys, what will be the answer here? Here they are saying aneuploidy is due to change in chromosome number. What are the reason? Addition is a reason, and deletion also another reason. Not substitution, not translocation, not inversion. So here answer will be what? Of A, B, and C. Option D. So aneuploidy means what? Change in few number of chromosome, and which is due to addition or deletion. Is it clear? Yeah, very good. Now, let's take the next question. 57th question. Match list 1 with the list 2. In list 1, you can see that they are given Down syndrome, thalassemia, alpha thalassemia, beta thalassemia, Klinefelter syndrome. In list 2, you can see 11th chromosome, X chromosome, 21st chromosome, and 16th chromosome. Guys, what will be the answer here? You know, Down syndrome is due to what? Trisomy of the 21st chromosome. Now, Down syndrome is due to trisomy of 21st chromosome. Hence, we can connect A with the 3. If we connect with A with the 3, yes, we are getting the answer. We are lucky, we are getting the answer. Yeah, very good, very good. So then just for confirming, we can match the remaining as well, right? Let's say alpha thalassemia, 4, 16th chromosome. Beta thalassemia, 11th chromosome. Klinefelter syndrome, X chromosome, right? Yes, very good. Next, 58. Which of the following statement is correct about Klinefelter syndrome? This disorder was first described by Langdon Down. Such an individual has overall masculine development, however, the feminine development is also expressed. The affected individual is short stature, physical, psychomotor, and mental development is retarded. Such individuals are sterile. Guys, what will be the answer here? You know what is Klinefelter syndrome, right? First of all, Klinefelter syndrome present in males, right? So what will be the ploidy? They will be having 44 autosome plus XXY condition. XXY condition. This is present in males. Here they are having, here they are having an extra X chromosome. They are having an extra X chromosome, right? Now let's see the statement. This disorder was first described by Down. This is incorrect because Langdon Down described a Down syndrome, not Klinefelter syndrome. Statement B, such an individual has overall masculine development. However, the feminine development is also expressed. This is true because this Klinefelter syndrome present in males, but they are also showing feminine characters like what? Development of breast or gynecomastia or development of breast is present in Klinefelter individuals showing Klinefelter syndrome. Hence, it is true. They affect they affected individuals is short stature. No, it is incorrect because this is a character of Down syndrome, not Klinefelter syndrome. Now, physical, psychomotor, and mental development is retarded. This also incorrect because this again a feature of Down syndrome. Now, such individuals are sterile. This is true because such individuals cannot reproduce or they are sterile. Hence, both B as well as E. Yes, option D will be the answer. Right? Yeah, very good, guys. All are answering. Next one. Which one of the following symbols represent mating between relatives in human pedigree analysis? Which will be the answer, guys? Here they are asking mating between relatives. If mating between relatives comes, this is called consanguineous mating. This is called consanguineous mating. Consanguineous mating means mating between relative individuals. Yeah, answer will be C, right? This is normal mating, which means the mating between unrelated individuals or unrelated family. This is within the same family or relatives. Consanguineous mating. Very good. Now, broad palm with a single palm crease is visible in a person suffering from thalassemia, Down syndrome, Turner syndrome, and Klinefelter syndrome. What will be the answer here? Broad palm with a single palm crease. Guys, this is nothing but Down syndrome. Now, what is the another character? You need to know characters of each diseases, especially Down syndrome. You need to know what all the symptoms. For example, congenital heart disease is a feature of Down syndrome. This point even you cannot find as a line in NCRT, but this is given in the picture. Okay, remember it. Disorders part are very, very important for your NEET exam. Now, 61 guys. Given below are two statements. Statement 1, sickle cell anemia and hemophilia are autosomal dominant traits. Statement 2, sickle cell anemia and hemophilia are disorders of the blood. What will be the answer? Yeah, protrutrang is another character. Very, very, very good, Nitya. Now, so make sure you are making a list out of it. Okay, because you need to remember this all the time. Now, sickle cell anemia and hemophilia are autosomal dominant trait. It is incorrect, guys. Why? Because sickle cell anemia is an autosomal recessive disorder. Hemophilia is an X-linked recessive disorder. Hence, statement 1 is wrong. Statement 2, both sickle cell anemia and hemophilia are disorders of blood, which is correct. Right? What is the difference? Hemophilia means clotting of blood is affected. Clotting of blood affected. What about sickle cell anemia? In sickle cell anemia, the RBC changes, right? Their shape changes into sickle-like structure, right? And because of that, there will be many problems. And sickle cell anemia also related to blood. Hence, second statement is true. So, what will be the answer? Statement 1 is incorrect, but statement 2 is correct. Option A will be the answer, right? Very good, guys. Very good. Now, let's take the next question. 62. If a female individual with a small round head, furrowed tongue, partially open mouth, and broad palm with a characteristic palm crease, also physical, psychomotor, and mental development is retarded, the karyotype analysis of such an individual will show. Guys, what is this? What are the options? Trisomy of 21st chromosome, 47 chromosome with XXY6 chromosome, 45 chromosome with XO6 chromosomes, 47 chromosomes with XXY6 chromosome. Here you can see that here they are explaining the characteristic features of Down syndrome, right? Down syndrome. So from this question, you can learn what are the characters of the Down syndrome. Now only you guys can study small round head, furrowed tongue, partially open mouth, broad palm with characteristic palm crease, physical, psychomotor, and mental development retarded. All these are characteristic features of Down syndrome, right? In now let's take option 1, trisomy of 21st chromosome. This is nothing but what? Down syndrome. This line indicate Down syndrome. So answer will be option A. Now, what is second option? What it indicate? 47 chromosome with a XXY condition. This is nothing but Klinefelter's syndrome. Now, next one. 45 chromosome with the XO6 chromosome. This is called Turner's syndrome. Now, 47 chromosome with the XYY6. This is not relevant for you. So, answer will be option A. Right? Very good, guys. Next one. Select the incorrect match regarding symbols used in pedigree analysis. Select the incorrect match. What will be the answer? Parent with the male child affected with the disease. Yes, this is true. Sex unspecified, true. Affected individuals, true. Consanguineous mating, this is wrong. What is missing here, guys? Here, an extra line is missing. Now this is correct. This is called consanguineous mating. Very good. Option D. Now, a normal girl whose mother is hemophilic. Guys, now we are getting into another kind of question. Some calculation type or pedigree matching. It's very, very interesting. Once you know the trick, it's very, very interesting. Okay. And you can see many questions from here for a NEET exam. A normal girl whose mother is hemophilic marries a male with no ancestral history of hemophilia. What will be the possible phenotypes of the offsprings? Let's see. So, a normal girl and the mother is hemophilic, right? Normal girl means what? Let me write XX here, and the mother is hemophilic. If mother is hemophilic, it represented by X dash X dash. Now, if this hemophilic mother is mating with her father XY, now at least X will be coming from father, another X will be coming from mother. So one X should contain X dash, right? Hence, the girl means what? X dash X. A normal, it's a carrier girl. Okay, phenotypically normal. Now this is marrying with a male with no ancestral history of hemophilia. So we can take it as a XY, right? Normal male. Now let's cross X dash X, X dash Y, X, X, and finally XY. Now you see, guys, what is this? This is carrier female. This is diseased male. This is normal female. This is normal male, right? Now, what they're asking, hemophilic son and hemophilic daughter. Do they have hemophilic son? Yes, hemophilic son is there, but they do not have hemophilic daughter. Only carrier daughter is there. Hence, this statement is wrong. Next one, hemophilic son and carrier daughter. Hemophilic son is correct, but carrier daughter, yes, carrier daughter also present. Hence, this statement is true. Normal daughter, normal son. Yes, normal son, normal daughter, normal son. True. Normal son, hemophilic daughter. Hemophilic daughter is not present. Only carrier daughter is there. Hence, it is wrong. So, what will be the answer? B and C. Option C. Very good, guys. All are answering. Option C is the answer. Next one. Which of the following occurs due to the presence of autosomal linked dominant trait? Thalassemia, sickle cell anemia, myotonic dystrophy, and hemophilia. Yes, give me the answer. Autosomal linked dominant trait. Answer will be myotonic dystrophy. Because what is thalassemia? Autosomal recessive. What is sickle cell anemia? Autosomal recessive. Hemophilia, X-linked recessive. See, when you are doing PYQ, you know what is the most important thing? You need to understand the correct answer. But more than that, you need to know Why others are not correct? Because that might be the next question in upcoming exam. And also you should be aware, the possible type of question that can be asked in the future from the same topic. That's the relevance of doing MCQs. I will try to explain maximum while I'm discussing here itself. Let's see. Now, in case of myotonic dystrophy, you have a picture in your NCRT. There they are given myotonic dystrophy. Under a pedigree, they have given myotonic dystrophy is an autosomal dominant disorder. This is an autosomal dominant disorder. Okay, fine. Very good. Now, if a colorblind female marries a man whose mother was also colorblind, what are the chances of her progeny having color blindness? So, colorblind female means what? Color blindness is an X-linked recessive disorder. If it is X-linked recessive disorder, color blindness is mentioned as X dash X dash. Colorblind female means X dash X dash. Marrying with a man means XY, whose mother was also colorblind. So this guy's mother was colorblind. If mother was colorblind, he will get at least one X dash from mother, na? Y will be coming from father. And X dash X will be coming from mother. So at least one X dash will be there. Now we need to cross, right? Yeah. X dash X dash X dash Y X dash X dash X dash Y. Now, what will be there here? X dash means what? Diseased female. This one diseased male. This one diseased female. Diseased male. So basically, here they are asking how many of the percentage of the progeny are colorblind. Progeny means what? Both male and female. Both male and female comes under progeny, right? So here you can see all are diseased. So answer will be option A. Yeah, everyone is answering. Very good, very good. Nice. Let's move to the next question. In a cross between male and female, both heterozygous for sickle cell anemia gene, what percentage of progeny will be diseased? So the cross is between male and female, heterozygous for sickle cell anemia. So how to write that? Let me write HBA, HBS, heterozygous. Let's say this is male. Let me take female as HBA, HBS. Here both are heterozygous. Now, what percentage of progeny will be diseased? We will cross it. HBA, HBA. Second probability, HBA, HBS. What is the third probability? HBA, HBS. And final thing, HBS, HBS. Right? So, this will be normal. This is carrier, and this is diseased. So how many will be diseased here? Diseased means what? Probability is 1 by 4, which means 25%. Option B. Yes, all are answering. Very nice case. Super. Let's do the next question. Select the correct match. In column A, you can see phenylketonuria, sickle cell anemia, thalassemia, hemophilia. In column 2, autosomal dominant trait, autosomal recessive trait on chromosome 11, X-linked, Y-linked. Quickly answer. Here they are asking correct match. Phenylketonuria, autosomal dominant trait. It is wrong. Why? Because phenylketonuria is autosomal recessive. Now, sickle cell anemia, autosomal recessive trait on chromosome number 11. This is true. So option B will be the answer. Thalassemia X-linked. Incorrect, because thalassemia is what? Autosomal linked, not X-linked. Right? autosomal linked. Hemophilia, not Y linked. Hemophilia is X linked, right? Fine. Hence, option B will be the answer. Yes, very good, guys, very good. Now, what is the genetic disorder in which an individual has overall masculine development, gynecomastia, and is sterile? Turner syndrome, Klinefelter syndrome, Edwards syndrome, Down syndrome. What will be the answer? Gynecomastia means what? Klinefelter syndrome, right? Now you see, based on features of chromosomal disorders, there are many questions which are coming for NEET exam. Okay, so you should be thorough with the features. Now 70. A woman has an X-linked condition on one of her X chromosome. This chromosome can be inherited by only daughters, only son, only grandchildren, both sons and daughters. Guys, what will be the answer here? It's a very simple question, right? So here they have mentioned women. Women mean XX has X-linked condition on one of her X chromosome, which means X dash X. So this chromosome can be inherited by, let's say, let me take male as normal. This is female. Now you see X dash X, X dash Y, XX, XY. Now you see this X dash is transferring to female as well as male, or both daughter and son. So it can be transferred into both sons and a daughter. Simple question, right? Very good. Now, 71. A disease caused by autosomal primary non-disjunction is. Guys, what will be the answer here? I want to know what is your answer. Options: Down syndrome, Klinefelter syndrome, Turner syndrome, sickle cell anemia. Disease due to autosomal primary non-disjunction. Here, see, primary non-disjunction mean there will be a failure in segregation of the chromatids. If there is failure in segregation of chromatids, they will get an extra chromosome, right? Which mean trisomy. So what will be the answer here? Here, answer will be option A. Now, but many people may make confusion when they are doing this question for the first time. You may think that autosomal mean sickle cell anemia. So sickle cell anemia could be an answer, but it's not like that. What you need to understand, Klinefelter syndrome is due to what? Klinefelter syndrome is XXY condition, na? But the problem is on X chromosome, sex chromosome, not on autosome. Hence, B is not the answer. Turner syndrome, what? XO condition, they are losing one X chromosome. Again, not related to autosome. Hence, this is also not the answer. Now, in sickle cell anemia is not, in case of sickle cell anemia, there is no change in chromosome number. In case of sickle cell anemia, what happened? Chromosome number is same only, but the structure is changing. For example, instead of glutamic acid replaced by valine, structure got changed, but there is no change in chromosome number. So if there is primary non-disjunction, then there will be a change in chromosome number. If it is on autosome, then change in the number of autosomal chromosome. Hence, what will be the answer? Down syndrome, because you know Down syndrome is due to trisomy of 21st chromosome. You know 21st chromosome is nothing but autosome, not sex chromosome, because first 22 pairs are autosome, then remaining one pair is sex chromosome. Is it clear, guys? Very good. Now, 72. Thalassemia and sickle cell anemia are caused due to problem in globin molecule synthesis. Select the correct statement. Both are due to qualitative defect in globin chain synthesis. Both are due to quantitative defect in globin chain synthesis. Thalassemia is due to less synthesis of globin molecule. Sickle cell anemia is due to quantitative problem of globin molecule. You see, thalassemia, sickle cell anemia. Select the correct match. What are the reason? You know, in thalassemia, the problem both are due to quality, which is wrong because in case of thalassemia, you know that the production is getting decreased, right? So quantity is decreasing. So thalassemia is a quantitative problem because globin production is decreasing. But when you take sickle cell anemia, you can see that what is the case of sickle cell anemia? You know, normal biconcave RBC changed into sickle shape, which means quality affected. There is no problem in quantity. Quantity remains same only, but quality got affected. So it is a qualitative problem. Qualitative problem. So what will be the answer? Both are quantitative. No. Thalassemia is due to less synthesis of globin molecule. This is correct because hence it is a quantitative problem. Sickle cell anemia is due to quantitative problem. No. Sickle cell anemia is what? Qualitative problem. Hence answer will be option C. Right? Very good. Now, if a colorblind man marries a woman who is homozygous for a normal color vision, the probability of their son being colorblind is. So colorblind man means X dash Y. Colorblindness is X-linked recessive disorder. Marries a woman who is homozygous for normal color vision, which means XX, male, female. Probability of son being colorblind. So here we only need to take son, which means male will provide only Y. XY, XY. Yeah. So what is the probability? Is zero probability. All are normal. Right? Very good. Now, pick out the correct statement. Hemophilia is a sex-linked recessive disease. Down syndrome is due to aneuploidy. Phenylketonuria is an autosomal recessive gene disorder. Sickle cell anemia is an X-linked recessive gene disorder. What will be the answer here? Tell me, guys. Hemophilia sex-linked recessive disease. True. Down syndrome is due to aneuploidy. True. What is aneuploidy? Aneuploidy means change in few number of chromosome like 2n plus 1, 2n plus 2, 2n minus 1, 2n minus 2, right? So in case of Down syndrome, this is nothing but 2n plus 1 or trisomy, right? Now, phenylketonuria is an autosomal recessive gene disorder, which is true. Sickle cell anemia is an X-linked recessive gene disorder. This is false because sickle cell anemia is what? Autosomal recessive disorder. Hence, what will be the option? A, B, C. Option D, na? Yeah, very good, very good. Now, which of the following is most appropriately describe hemophilia? A recessive gene disorder, X-linked recessive gene disorder, chromosomal disorder, dominant gene disorder. Hemophilia is an X-linked recessive disorder. It is not a dominant. It is not chromosomal because it is it's a Mendelian disorder, not a chromosomal disorder. It is Mendelian disorder. recessive gene disorder is correct. X-linked recessive gene disorder is also correct. But here we have to go with the most appropriate, which is most appropriate B. Hence, we are going with the option B, right? Very good. Now let's next. In the following human pedigree, the filled symbols represent affected individual. Identify the type of the given pedigree. Guys, very important pedigree based question. What will be the answer? Here you can see X-linked recessive, autosomal recessive, X-linked dominant and autosomal dominant. Here you can do one thing, guys. See, first of all, try to eliminate the things. Now you see here you can see that this is an affected individuals given to normal parent. If a diseased baby is born to a normal individuals, then which is not a dominant disorder, because it's not possible. If it is a dominant disorder, parent also will be diseased now. Here see, none of the parents are diseased, but one kid is affected. Hence, it is not a dominant disorder. We can remove it. Now the question whether it is X-linked or autosomal recessive. X-linked recessive or autosomal recessive. Let's try. Here you can see that. See, suppose imagine it is an X-linked recessive disorder. Now how we can work it out? If it is X-linked recessive disorder, let's say then it will be X dash Y, right? It should be X dash Y. This will be X dash Y. If it is X dash Y, okay. Here it's X dash Y. This also will be X dash Y. What it will be? X dash, right? Now you see here. Here, here there is a male. For this male, Y, let's say this is XY. For this male, Y will be coming from father. X should come from mother. Here, mother can contribute only X dash or diseased allele. Then it will be X dash Y na. If it is X dash Y, the son should be affected. But here, son is not affected. Because of that, it is not a X-linked recessive disorder. It will be autosomal recessive disorder. But we will confirm that. We will try to validate it. Okay, we can try to validate. You see, let me take another color. Yeah, you see here. You see here. For example, this will be small a. This will be small a small a. This is small a. So this could be capital A or capital A small a. And here daughter is there. Daughter will be capital A small a. Son will be capital A small a, because one small a should come from mother. Here what? Capital A or capital A small a. This will be small a small a. If it is small a, then one parent has to be capital A small a, which means everything is working. If you start writing a pedigree, you won't it won't create any problem. You can match everything, which confirm that B is the answer. When you practice more and more, you will start guessing actually. Then finally you just need to verify it. Okay, fine. So here answer will be option A, option B, right? Is it clear, guys? Pedigree is very, very important. Okay, now a colorblind man marries a woman with a normal sight who has no history of color blindness in her family. What is the probability of their grandson being colorblind? Nice question. So here, colorblind man, which means X dash Y, marries a woman XX with a normal sight who has no history of colorblind in a colorblind in her family. Now, what is the probability of grandson being colorblind? Let's see. So X dash Y with the normal women, so XX. Let's me cross it. X dash X will be coming X dash X, XY, XY. Right? Now you see this diseased allele only passing into the female, not into the male. Right? Now let me take the female separate. I'm taking this female separate. Okay. This female is X dash X. And let's say crossing with the another male because we need to get a grandson now. Our question is about grandson, not son. Now marrying with a guy. This is this is daughter. This is this is a guy. Now let me cross it. X dash X, X dash Y, XX, XY. Now what they're asking, what is the probability of their grandson being colorblind? What is the probability, guys? Here you see, this is carrier daughter. This is diseased son. Normal daughter. Normal son. So what is the probability, right? The probability of color grandson being colorblind is 1 by 4, no? Which means only 1 out of 4 are colorblind. So 25%. 25% means what? 0.25. Right? 1 by 4 is equal to 0.25. Clear? Yeah, fine. Now, a human female with a Turner syndrome is able to produce children with a normal husband, has 45 chromosome with XO, has one additional X chromosome, exhibit male characters. Human female with the Turner syndrome. Turner syndrome means what? XO condition. Is able to produce children with the normal husband. Has 45 chromosome with the XO. This is true now because they will have 44 autosome plus X0, which means 44 autosome plus 1 X chromosome. Total 45 chromosomes. Option B is the answer. Has one additional X chromosome? No. They have only single X chromosome. Exhibit male character? No. Turner syndrome people only exhibit female character. Only female characters. Right? And what are the characters of Turner syndrome? Remember, sterility. They are not fertile. Some problem with the secondary sexual characters. All this you need to be learned. Okay. Now 79. A man whose father was colorblind marries a woman who had colorblind mother and normal father. What percentage of male children of this couple will be colorblind? Let's see. A man whose father was colorblind. Man means XY. Whose father was colorblind means what? Father is X dash Y. Let's say, let me take mother as normal. So he will get this Y from father, X will be from mother. So means this guy is normal XY only. Marries a woman. Women mean XX who had a colorblind mother and normal father. Colorblind mother means what? X dash X dash. and normal father means XY, right? So here you see one X will come from father, another X should come from mother na, and mother has only X dash. So this guy will be X dash X. See, you need to know this thing. If you know this thing, you succeeded, right? So now you cross X dash X, then XX, then X dash Y, then XY. Now what is X dash X? Carrier female. What is XX? Normal female. Carrier female, normal female. Now what is X dash Y? Diseased female. And what is XY? Normal male. So here the question, what percentage of male children of this couple will be colorblind? So they have two male children. So here actually, here we only need to consider two things. Only this and this. Alright, this is hmm, let me make it simple for you. When this comes now, since they're asking only male children, you only need to take Y from the father, which means X dash Y, XY. So out of two, this is diseased male or diseased son. This is normal male or normal son. So how many are affected? 1 by 2, which means 50 percentage, right? Option D will be the answer. Clear? Fine. Now, 1780. The incorrect statement with regard to hemophilia. A single protein involved in clotting of blood is affected. It is a sex-linked disease. It is a recessive disease and it is a dominant disease. What is the incorrect statement regard to hemophilia? Single protein involved in clotting of blood is affected. Fine. It's a sex-linked disease. Fine. It is a recessive disease. Fine. It is a dominant disease. No. Hemophilia is an X-linked or sex-linked recessive disorder. Hence, it is incorrect. So, D will be the answer. Very good. Now, 81. If both parents are carriers for thalassemia, which is an autosomal recessive disorder, what are the chances of pregnancy resulting in affected child? Both parents are carrier for thalassemia, which means HbA, HbS. Let's say this is father. Let's say mother is HbA, HbS. This is mother. Now, what are the chances of pregnancy resulting in affected child? Let's see. Let me cross HbA, HbA. What is second? HbA, HbS. What is next? HbA, HbS. What is the fourth one? HbS, HbS. Now you see, tell me the character. This is normal. This is carrier. This one carrier. This one diseased. Right. So what will be the answer? Only 1 out of 4 children are diseased, which means 25% is affected. So the answer will be option D. Yeah, very good. D again. Now, one question for NEET 2026. I think, which of the following statement is correct? Correct regarding haplodiploid sex determination system observed in honeybee. Drones have 32 chromosome and produce sperms by meiosis. Drones are formed parthenogenetically from unfertilized eggs and possess 16 chromosome. Queen and workers are males developed from fertilized egg. Drones have both father and grandfather. We need to identify the Correct one. Drones have 32 chromosomes and produce sperm by meiosis, which is incorrect. Drone mean what? Drones mean male honeybee. It will have only 16 chromosomes and they are produced by mitosis, not meiosis. Hence, this statement is wrong. Drones are formed parthenogenetically from unfertilized egg and possess 16 chromosome, which is true now, right? So, you know that if there is a female gamete with 16 chromosome, which is N, it will undergo parthenogenesis. Means here there will be mitosis and they will be producing drone. Drone means what? Male honeybee, right? And what will be the chromosome number? Chromosome number will be N, which is 16. So statement 2 is correct. Queens and workers are males developed from fertilized egg. No, queen and workers are females, not males. Drones have both a father and grandfather. That is true, right? So when you take drone is having um father. No, which is wrong. Drone only have mother because it directly formed from female gamete, right? And drone, they have mother, they do not have father. Let me show this for you guys. So when you take a, let's see what happening. For example, um, a female having n 2n is equal to 32, it will produce gamete, right? Let's say this is producing two gametes by meiosis. This gamete can directly form drone, as previously mentioned here, through parthenogenesis. So ploidy will be N or 16 chromosome. So now what happens when you take a drone? When you take a drone, this drone means what? N. It can produce male gamete. This may combine with another female gamete and they will produce female with the 2n is equal to 32 chromosome because this is n, this is n plus n 2n, 32 chromosome, right? So here you can see that drone are having mother but do not have father, but they have grandfather because this mother formed from a father only. Now drone can have daughter but not son, right? And but they can have grandson because this female can produce another son, so they can have grandson. Okay, I hope you know all these things. Now continuous variation across an entire population range like human height, human skin pigmentation shows a gradient of intermediate phenotypes. The pattern is explained by pleiotropy, where a single gene regulates multiple phenotypic traits, polygenic inheritance, where multiple independent genes additively control a single trait, multiple allelism, when more than two alleles control a single trait in an individual. Now, incomplete dominance, where a single pair of alleles blends completely. Is what will be the answer here? Here they're asking human skin height, human skin color, skin pigmentation. You know that all these are related to polygenic inheritance, not pleiotropy. It is related to polygenic inheritance, not related to multiple allism, not related to incomplete dominance. So answer will be Option 2. Right? Very good. Now, given below are two statements regarding sickle cell anemia. Statement 1, it's very good question. The defect is caused by substitution of glutamic acid by valine at the sixth position of the alpha chain of hemoglobin. Then single base substitution occurs at the sixth codon of the template strand of DNA, changing from GAG to GTG. Guys, what will be the answer here? Tell me. Here, in case of sickle cell anemia, defect is caused by substitution of glutamic acid by valine at a sixth position. These two are correct, but not alpha globin. It is beta globin chain. Hence, statement 1 is wrong. Now, statement 2. A single base substitution occurs at sixth codon of template strand of DNA from GAG to GTG. Is it correct, guys? No. Why? Because in DNA, what changes will be happening? We know glutamic acid converting into valine. In DNA, what changes will be happening? For that, you need to know what happening in mRNA. If you take mRNA, you know that in a mRNA, GAG will be converted into GUG, which means GAG convert into GUG, right? GAG converting into GUG. Now, in case of DNA, what will happen? You know what is the relation between template? Yeah, you know what is that uh, connection between template strand of DNA and the mRNA? You know that, right? They will be complementary, which means G means what? C. A means T. G means C. G means C. U means A. G means C, which means in DNA, CTC will convert into CAC. In mRNA, GAG will be converting into GUG. So here they have mentioned that in DNA, GAG to GTG. It is not correct. So what will be the correct? CTC to CAC. But if the question, let's say in coming NEET exam, they are framing the question like in mRNA, how it will be changing. So in mRNA, it will change from where? GAG to GUG. In DNA, template strand of DNA changing from CTC to CAC. Now the question, what about coding strand? In case of coding strand will be just complementary of this one, right? Fine. Good question for learning. Now, chromosome, in which of the following organism does the male possess fewer total somatic chromosome than female due to sex determination profile? Drosophila melanogaster, locust, fowl, Homo sapiens. Guys, you know that here answer will be grasshopper. Why? Because they shows XX, XO type. Female have two X chromosome, but male have only one chromosome, right? So there is a difference in number of chromosome between male and female, right? In case of Drosophila melanogaster, they show XXXY, which means there is no change in number of chromosome. Even Homo sapiens same XXXY. There is no change in number of chromosome, right? Now, next question, guys. Question 4. In which of the following organism does the male possess fewer total somatic chromosome than the female due to its sex determination profile? Drosophila melanogaster, Locusta, fowl, and Homo. I think same question repeated, right? Yeah. What will be the answer? Grasshopper. Now, here match list 1 with the list 2 regarding Mendelian inheritance. List 1, incomplete dominance, codominance, pleiotropy, polygenic inheritance. List 2, human skin color, phenylketonuria, flower color in antherinum, ABA blood grouping. Guys, How can we connect? Incomplete dominance can be connected with the flower color in antherinum, A3. Yeah, we are lucky. We got the answer. Now B4, codominance, ABO blood grouping. Yeah. C2, pleiotropy, phenylketonuria. D1, polygenic inheritance, human skin color. Right? Yeah, very good. Now, if two individual hetero, it's a very nice question, guys. Okay, make sure you are understanding it properly. If two individual heterozygous for blood group A and blood group B marry, what is the probability of them producing an offspring with the blood group O? So, two individual heterozygous for blood group A and B. Probability of producing offspring with the blood group O. It's simple question, right? I thought it's a different question. Blood group A means IA small I with the IB small I. What is the probability of O? You know, O is represented by small I, right? So IA, IB, another one, IA, small I, then IB, small I, then small I. Guys, what will be coming here? This is AB blood group. This is A blood group. This is B blood group. And the final one, O blood group. What is the probability of O? 1 out of 4, which is 25%, right? Option 3 is the answer. Clear? Easy one. Now, if two genes A and B are situated very close to each other on same chromosome, same autosome, which of the following outcomes would you expect to notice in a classic dihybrid test cross configuration? So here, four options are there. A phenotypic dihybrid ratio of 9:3:3:1 in a progeny, recombinant types appearing significantly higher frequencies in parental type, generation of 1:1:1 test cross ratio, a significantly higher proportion of parental phenotype compared to phenotypes. Answer this, guys. Very simple question. So here they have mentioned that, um, two genes are present on the same chromosome, right? If two genes are present on the same chromosome, you know that there will be a process called, I got some other messages. Okay, fine. So if two genes are present on the same chromosome, you know that there will be a process called a linkage, right? If linkage is there, we won't get 9:3:3:1. In case of linkage, we won't get 9:3:3:1. This will be possible when there is independent assortment. Independent assortment will be possible if there are no linkage. Got it? Now, recombinant types appearing in significantly higher frequencies in parental type. No, than parental type. No, because if there is linkage directly proportional to parental. No, sorry. Yeah, parental type, which is inversely proportional to recombinant types. Means if linkage is more, parental will be more. Parental frequency will be more. Recombinant frequency will be less. Hence, it is wrong. Generation of 1:1:1 test cross ratio. Again, guys, since linkage is present, test cross ratio won't be this. This we will be getting in a normal test cross. A normal test cross. If there is no linkage, yes, we will be getting this ratio in test cross. But since there is linkage, this is not possible, right? Significantly higher proportion of parental phenotype compared to recombinant. Yes, this is true. If linkage is more, parental is more, recombinant less, right? Very easy. So when you are reading this statement, you need to understand when they say genes are close to each other, you need to understand there is linkage. Next, it's a very nice question. Gene R and Y follow independent assortment. If a cross is performed between homozygous round yellow seed plant and wrinkled green seed plant, what will be the individual fraction of recombinant phenotype expected specifically inside total F2 generation? Gene R and Y follow independent assortment, which means there is no linkage. If cross performed between homozygous yellow seeded plant, round and yellow, which means capital R, capital R, capital Y, round and yellow with the wrinkled green seeded, which means small r, small y. Now they're asking what will be individual fraction of recombinant phenotype expected specifically inside F2 generation. See, basically they're asking what? Recombinant type. That's it. Now, if we cross this, what we will be getting? Capital R, capital Y, small y. This is normal dihybrid cross. In normal dihybrid, this is F1. If you self F1, you will get dihybrid phenotypic ratio. You know that what is the normal dihybrid phenotypic ratio? 9 is to 3 is to 3 is to 1. What 9 indicate here? Both dominant. What 3 indicate? One dominant, another recessive. What next 3 indicate? Recessive dominant. What 1 indicate? Both are recessive. Here they are asking recombinant. Now, recombinant means what? One parental, another. Recombinant means non-parental. Here you see, this will be 9. Let's say, for example, if you take 9, you can see 9 will be round yellow. 3 will be round green. Next 3 will be wrinkled yellow. This will be what? 1 will be what? Wrinkled green. This is round yellow. Now you see round yellow is parental na, wrinkled green parental na, but round green and wrinkled yellow are recombinant. So how many are recombinants here, guys? 3 plus 3, which means 6 out of 16 are recombinant. Option 2 is the answer. Right? Easy one. Now another question. A woman with the blood group AB and heterozygous for it's a very nice question, guys. Okay. Yeah. A woman with a blood group AB and heterozygous for RH factor marries a man with blood group O who is RH negative. What is the probability of them having child with the blood group B and being RH negative? Let me do this. Women with the blood group AB, which mean let's say IA, IB, heterozygous for, okay, this we will consider later, marries a man with the blood group O, which means small I, AB, O. Now RH negative, okay. What is the probability of them having child with the blood group A, B? Let me cross it. IA IA small I, IB small I, IB small I. A blood group, A blood group, B, B. So what is the probability of having B blood group? Which is 2 by 4, which means 1 by 2. So half part of the question is done. Now there is one more thing. Now we have to cross RH factor. When you consider RH factor, 1%. Women is RH positive, RH negative. RH plus, RH negative. With another women, RH minus, RH minus. RH negative, RH negative. Now we need to cross it. How to cross? RH plus, RH negative. Now RH positive, RH negative. Now RH negative, RH negative. Now RH negative, RH negative. Now you see the probability. How many of them are RH negative? RH negative means RH negative means RH negative, RH negative. How many of them? This is RH negative, this is RH negative, which mean 2 by 4, which mean 1 by 2. See the probability of, you see here, probability of RH negative is equal to 1 by 2. Now, what is the probability of B blood group? Probability of B blood group, which is also equal to 1 by 2. Now, the question is, what is the probability of, let me write here, probability of um, B blood group as well as RH negative. Probability of B blood group as well as RH negative. Sorry. So here answer will be what? We need to multiply this. Probability of B is what? 1 by 2. Probability of RH negative 1 by 2. So 1 by 2 into 1 by 2, 1 by 4. Yes. 1 by 4 means what? 25. This is the answer. Right? It's a very nice question, guys. Very, very nice question. I don't know how many of you will be able to answer this if you see this question first time. Very nice question. Okay. Make sure you will be practicing it. Note it down. Nice question. Now, let me move. Is it clear, guys? I hope it's clear. Let me move. Given below are two statements. Assertion: a test scores is always used to determine whether an individual displaying dominant phenotype is homozygous or heterozygous. Reason: in a test cross, individual with unknown dominant genotype is crossed with homozygous recessive parents. Let's see. In a test cross is used to determine individual displaying dominant phenotype, homozygous or heterozygous. True. True. For example, when we say, if I say tall, what will be the genotype? There are two probability, capital T or capital T small t. We don't know what exactly it is. So what we can do? We can do test cross. What is test cross? We will cross these two with the small t, right? This is called a test cross, right? So test cross is used to determine the genotype of the unknown, right? Yeah, it is true. Now, reason: in a test cross, the individual with the unknown dominant genotype is crossed with the homozygous recessive parent. Yeah, true. See, here we are crossing with the homozygous recessive parent. This is the unknown. So this is true. Is it a correct reason? For understanding correct reason, try to read first read assertion, then try to say reason, right? So I can say a test cross is used to determine whether an individual displaying dominant phenotype is homozygous or heterozygous because in a test cross, the individual with an unknown dominant genotype is crossed with homozygous recessive. Both are correct. So what will be the answer here? Option A. Both are correct and correct explanation. Right? Yeah. Nice. I think done, right? Yeah, yeah. So the chapter is over. So yeah, we covered even. So I think we discussed almost 90 to 100 question. I feel that this is, I mean, now what is the benefit of discussing PYQs, guys? First of all, it is giving a clarity how the questions are framing. That is the number one use. Second one, you are understanding what are the most important topic. We know that all are important, but still there are more preferences for some topics. I hope if you are with me from past 2 days, we have went through almost every question asked in NEET exam as well as a related exam in last 15 to 20 years, right? So by going through this question, you will have a proper clarity how the questions are coming, which topics they are choosing more frequently, how they are framing. What I understood, they are focusing on some. There are topics, some topic which are highly important, and as well as if you see the question in multiple years, they are simply changing the question, right? They are making some adjustments. So whenever you are going through PYQ, identify the topic, really work on it. Check what are the different types of question that they can ask from this topic. Be prepared for it, right? And try to explore the maximum varieties of question. If you do this, this will be enough for this chapter. And you know that this chapter can give you average 5 to 6 question for a NEET exam, which is mean 20 to 25 question or 20 to 25 marks. Even 1 mark can, make uh create a lot of change in your ranks. So never ever miss even single question from this chapter, because not everyone gonna answer for question from this chapter, at least all the questions. So if you are answering, you are in the lead. Okay, that's it. So then we will see with some other chapters very soon. Whatever your experience, just comment in comment section, so it will be useful for others. Okay, so we'll see you next class. Take care. Bye.